Hey everyone, my name is Tony. Now I'm going to try to discuss 10 first question in Cambridge IGCSE for physics. Okay, here I already opened a paper, past paper of course, October and November 2020. Okay, let's see the question. Okay, the first question. The diagram shows a pendulum. The pendulum bob swings repeatedly between points M and N. A student starts a stopwatch when the bob reaches point M. He counts each time the bob changes direction and stops the watch on the 10th change in direction. The watch shows a time of 12.0 seconds. What is the period of the pendulum? Okay, remember to find the period of the pendulum, you have to understand the definition first. Period is the time taken for one complete oscillation. Okay, so here we already know the time for some oscillation, which is 12 seconds. So we have to know first how many oscillation does it make. Yeah, we can use this information, everyone. Yeah, he count each time the bob change direction and stop the watch on the 10th change in direction. Okay, you can count. Yeah, remember from M to N and back to M. Yeah, it's only one complete oscillation. So if it has 10th change in direction, that's mean we have 5 oscillation. Okay, now and then you can use your calculator. 12 seconds for 5 oscillation. Okay, so that's mean the period of the pendulum is 2.4 seconds. Okay, yeah, remember period is the time taken for one complete oscillation. Okay, come on, number 2. Okay, this is about graph. The speed time graph represents a journey. How does the graph show that the distance traveled in section X of the journey is greater than the distance traveled in section Y? Okay, here the graph show us about the speed versus time. Now, and then the area under the graph represent the distance traveled. Now, so from this graph, we can see that the area under X is higher than the area under a Y graph. So the answer is A. Okay. The area below section A of the graph is greater than the area below section Y. Okay. Yep. I think it's easy for this one. Okay, continue. Number 3, a boy throws a ball vertically upward with a speed v. Okay, this is the diagram. And then which row describes the speed and the acceleration of the ball at point X on the way upwards? Okay, remember, maybe you also have experience, yeah, when you throw something upward, of course, the speed will be decreasing. Yes, so it will be decreasing, and then you can just eliminate option C and D. Okay, now we can just focus on option A and B. And then for the acceleration, okay, you see, yeah, the motion is upward, but then the speed is decreasing. That means the acceleration is opposite, yeah, to the motion direction. That means the acceleration is downward. So the correct answer is B. Okay, continue. Number 4, a student compares the weight of different objects. Which apparatus does he use? Okay, balance, measuring cylinder, stopwatch, thermometer. I'm sure you already know the correct answer, right? Of course, the correct answer is A. Yeah, balance. We use measuring cylinder to measure volume. Okay, stopwatch to measure time, thermometer to measure what is it? Temperature. Yeah. Okay, number 5. Which quantity is weight an example of? Okay, acceleration, force, mass, or pressure. Okay, weight is actually gravitational force. Yeah, gravitational force. So the answer must be force. Yeah. Okay, because weight is actually gravitational force between an object and the earth. Yeah, let's say because in this case, the object on the earth. Okay, so the answer is B. Okay, continue. Number 6. A metal ball is attached to a cork and is lowered into a measuring cylinder, pulling the cork into the water as shown. Okay, the mass of the cork is 4.8 gram. What is the density of the cork? Okay, here, density, remember the equation to find density? Correct, yeah. Density equals to mass over volume. Okay, so here we already know the mass of the cork, which is 4.8 gram. And then from this diagram, we can determine the volume. Okay, we use this measuring cylinder, yeah. And okay, it's quite different because here we have two objects, the cork itself and also the ball, and then the water. Now, because we are just going to know what's the volume of the cork, so we can just ignore the first figure. Yeah, we can just focus to this one. Yeah, when the ball is already submerged into the water, and the volume of the water and also the ball here is 56 centimeter cubic. Yeah, and then when we submerge also the cork, now the volume become 80 centimeter cubic. So the difference between these two diagrams is the volume of the cork itself. Okay, so let's count 80 minus 56. Okay, 24. Yeah, so 24 centimeter cubic is the volume of the cork. Yeah, 24. Okay, now, and then here, the mass is 4.8. So based on the equation, yeah, density equals to mass over volume. So it has to be 4.8 divided by 24. Okay, so we get 0.2. Yeah, okay, yeah. Here, the answer is B, 0.2 gram per centimeter cubic. Okay, I hope it is understandable for you, everyone. Okay, and then number 7. A uniform plank rests on a pivot at its center. Two children P and Q sit on the plank in the position shown. Okay, this is the diagram. Okay, child P and child Q. Okay, they are playing seesaw. The mass of child P is 25 kilogram and the plank is balanced. What is the mass of child Q? Okay. This question is talking about what is it, turning effect. So because it's balanced, so the turning effect in both sides is has to be balanced also. Yeah, it has the same magnitude. So when the mass of child V is 25 kilogram, you can just multiply by 1.2 meters, so you can get the turning effect. Okay, let me show you. Okay, the mass is 25. Okay, and then times, and the distance or the radius, yeah, between the child and the biped is 1.2. Okay, so 25 times 1.2. Okay, and then we get 30. Okay, and then we get 30. Then the turning effect in the right side, it has to be also 30. Yeah, because the position is equilibrium or the position is balanced. Okay. Now if the turning effect in the right side is 30 and the radius is 1.5, yeah, so what is the mass? We can just divide it. Is 30 by 1.5. Okay, and then we get 20. Okay, let's see. Yep, so the answer is A, 20 kilogram. That's the mass of child Q. Okay, next, number 8. An object is in equilibrium on the Earth. Which statement is correct? All the forces acting on the object are in the same direction. All the forces acting on the object have the same value. The object is weightless. The resultant force acting on the object is 0. Okay, which one is the correct answer? Yep, the correct answer is D. Okay, remember the first law of Newton. Yeah, it states that when there is no, if the resultant force that acting on the object is equals to 0, so the object will be stay at rest, yeah, or moving at constant speed. And in this case, yeah, an object is in equilibrium. Yeah, we can say that the object stay at rest. Okay, so the answer is D. Yeah, D. For C, I think, yeah, this option must be the first option that we have to eliminate because it's mostly impossible for object is weightless, right? And then all the forces acting on the object have the same value. Okay, this one is also impossible. Not impossible, I mean, yeah, because the same value that may not equilibrium. Yeah, what if it has the same direction? Of course, it will not in equilibrium, right? It will moving. Yeah, the object will move to a direction. Okay, and then number 9. A man jumps from a stationary balloon. After falling several hundred meters, he opened his parachute. At which position is his kinetic energy greatest? Okay, you can imagine, yeah, this man jumps from a stationary balloon. Of course, the initial velocity equals to 0 because the man yeah, initially it's not moving, of course, yeah. So initially the velocity equals to 0, and then when he jumps, the velocity increase, yeah, increase until the man opened the parachute. When he opened the parachute, the velocity drops significantly, and then the best answer for this question is B, yeah, just before he opened his parachute. Yeah. Okay, so the velocity will increase, and then just before he opened his parachute, that's the what is it? The greatest kinetic energy. Yeah, because after that, the kinetic energy or the velocity will drop significantly. Yeah, remember, kinetic energy is directly proportional to the velocity. Yeah, remember the equation: kinetic energy equals to half of mass times velocity square. Okay, the last question. The arrows show an outline of the processes in an oil-fired power station. Yeah, oil is burned and then turns turbine and then turns generator and then output transformer. Okay, what are the processes for the transfer of energy between the turbine and the generator and between the generator and the output transformer? Okay, here, yeah, turbines to turns generator. Yeah, it's actually object moving, make another object moving. So in this case, it's just mechanical working. Yeah, mechanical working. So we can just eliminate option A and D. Yeah. And then for generator to output transformer, not this one, in generator we have kinetic energy because this generator we have a part that's rotating, yeah, or moving. And then output of transformer here is what is it? Electrical energy. Now, so in this process, it's convert from kinetic energy to electrical energy. So I think the best answer for this one is B. Yeah, for the generator to output transformer is electrical working. Okay, everyone, that's all for now. Hopefully, you understand what I just explained to you. The first 10 question in this Cambridge exam of physics for winter last week. Yeah, if you have further question or need more explanation, please yeah, comment below. Okay, thank you, everyone. Bye bye.